Okay, welcome to the part 5 of this chapter 1 on exercise 1c. Problem here is on 7, 2. The first 7, 1 we have done on part 4, and here we'll be doing on 7, number 2. Finding the HCF and LCM of 84, 90 and 120. Okay, solution for this, we have to find the factors of 84, 90 and 120. Factors of 84, 2 4s are 8, 2 2s are 4, 2 2s are 4, 2 1s are 2 and 3 7s are 21. Okay, 84, the factor of 84 are 2 square multiply 3 multiply 7, and then 120 and 90 also you will get as 2 3 square multiply 5, 120 as 2 cubed multiply 3 multiply 5. Okay, now the LCM. What is the LCM? LCM is the product of prime factors. What is the common product of the common prime factor? What is the common prime here? 2 2 2, 3 3 3, 7 is not common, 5 also is not common. That means 2 and 3 they are the common primes. Now look for the lowest power. 2 power 2, here 2 power 1, 2 power 3. Which is lowest? 2 power 1. If a power is not given, that means you should assume that it is having 2 power 1. Okay, that means 2 power 1 is the lowest, and 3 also, 3 power 1, 3 power 2, 3 power 1. Which is lowest? 3 power 1. That means HCF will be just 2 multiply 3, which is 6. And the LCM will be the product of each prime with highest power. Now what are those prime between these three, among these three numbers? They are 2, 3, 5 and 7. There are 4 prime factors of this number: 2, 3, 5 and 7. 2, 3, 5, 7. Now check for the highest power. 2 is high, 2 power, the highest power of 2 is 3, highest power of 3 is power 2, and 5 is 1, 7 is 1. 2 3 is 8, 2 3 square is 9, 5 and 7. On multiplying you will get 2 5 2 0. Clear? Second number from here, 112, 144 and 168. The same thing, you will find the prime factorization of all these three numbers. You will get as 112 as 2 power 4 multiply 7, 144 as 2 power 4 multiply 3 square, and 168 as 2 cubed multiply 3 multiply 7. Now check for the common prime. 2 is common, 7 is not common, 3 is not common. Therefore only 2, which is a common factors, common prime. Now look for the lowest power. Here we have 2 power 4, here we have 2 power 4, here we have 2 power 3. Which is highest? Lowest is 2 power 3. 2 power 3 means 2 multiply 2 multiply 2, which is 8. And the LCM. What will be the LCM? Product of each prime. You have the prime here, you have 2, 3, then 5 is not there, you go to 7. 2, 3 and 7. Okay, now check for the highest power. 2 power 4, 2 power 4, 2 power 3. Highest is 2 power 4. 3 power 2, 3 power 1. Highest 3 power 2, and then 7 power 1. 2 power 4 is 16, 3 square is 9, with 7, which is, on finding the product we will get 1008. Clear? Now 9. Find the smallest number when divided by 35, 56 and 91. You leave remainder 7 in each cases. Okay, what you'll do, first you find the prime factors of 35, 56 and 91, and then find the LCM of these three numbers. For 35 is 5 7, 56 is 2 multiply 2 multiply 2 multiply 7, that means 2 cubed multiply 7, and 91 is 7 multiply 13. Now the LCM of this will be the product of primes, which is 2, then 5, then 7, then 13. 2, 5, 7 and 13, isn't it? Hence the LCM will be 2, 5, 7, 13. Now check for the highest power. Highest power of 2 is power 3. Highest power of 5 is 1. Highest power of 7 is 1, and 13 also 1. Now 2 power 3 is how much? 8. 8 multiply 5 multiply 7 multiply 13, you will get as 3640. Now this 3640 is the LCM, which is a common multiple of 35, 56 and 91, or you can say that this 3640 you can exactly divide it by 35, 56 and 91. Now if you want to leave remainder in each case, then you have to add this LCM with 7, which give us 3647. Now this number definitely, if you divide by 35, 56 and 91, will leave 7 as remainder in each cases. Clear? Number 10. Find the smallest number which when increased by 11 is exactly divisible by 15, 20 and 54. Here also the same thing. You will find the SAF on the not SAF, the LCM of 15, 20 and 54. Okay. Now to find the LCM, what we'll do, we'll factorize 15, 20 and 54 separately. 15 is 3 multiply 5. 20 is 4 multiply 5, or 2 multiply 2 multiply 5, that is 2 square multiply 5. 54 is 2 multiply 3 multiply 3 multiply 3, that is 2 multiply 3 cubed, and the LCM will be the product of each prime. This means 2, 3, then 5. 2, 3 and 5. Okay. Now 2, 3 and 5. What is the highest power of 2? Here we have 2 power 2, 2 power 1. Highest is 2 power 2. 3 power 3, 3 power 1. Highest is 3 power 3. And 5 power 1, 5 power 1. Highest is 5 power 1. Then 2 square is 4, 3 cubed is 27, and 5 on multiplying you will get 540. Now 540 is a number divisible by these three numbers. Now what should be the smallest number will increase by 11. That means if 540 is exactly divisible by this number, if you minus by 11 you will get 529. Then this 529, this number 529, if we add, we increase by 11, how much we will get? 540, which is divisible by all these three numbers. Hence the required number will be the LCM subtract by this 11, which will be 529 is the required number. Okay. Next, number 11. Find the greatest number of 6 digits which is exactly divisible by 24, 15 and 36. Okay. Now what we'll do here, the same thing, we'll find the LCM of 24, 15 and 36. Okay. How will you find out the LCM? By finding the factor of 24, 15 and 36. Now check for what are those prime factors of these three numbers. There are 2, then 3, then 5. 2, 3 and 5. Now highest power of 2, here we have 2, 3, 2 power 2. Highest is 2 power 3. Then 3, highest is power 2, and 5 is having power 1. 2 cubed is 8, 3 squared is 9, and 5 you will get 360 on multiplying all three numbers. Okay. Now the greatest 6-digit number exactly divisible by these three numbers should be a multiple of 360. This means okay, let us we know that the greatest number of 6 digit is 999999. Okay. Now the greatest number of 6 digit divisible by these three numbers should be a multiple of 360, because 360 is a LCM of these three numbers. Now let us try to find out the greatest number which is a multiple of 360. What you'll do, you'll divide 999 by 360. If you divide this, you will get 2777, leaving you a remainder of 279. That means if you subtract 279 from this greatest 6-digit number, will give you a number which is divisible by 360, because you have subtracted by this remainder. That means you will get a number which is exactly divisible by 360. Now if this number is exactly divisible by 360, it will also be exactly divisible by those three numbers, as 360 is their LCM. Clear? Next we come to the number 12. Can two positive number have 8, 1, 2 and 28 as their LCM and HCF respectively? Okay. Now those two numbers they have not given us. We have to find out. We have to check. We have to they ask us to whether those two numbers, they ask us to verify or to give an argument that can two numbers have 8, 1, 2 and 28 as their LCM and HCF respectively. Okay, now since 28 is the HCF, what is actually HCF? HCF is the highest common factors. That means each of these numbers should have 28 as one of its factors. Okay. Now knowing this, let us take one number as 20x and the other number as 28y. We didn't know x and y, but this 28, since is the HCF, we can take first number is a 28 multiply with unknown quantity x, and the other number is 28 multiply unknown quantity y. Okay, now we know that the product of two numbers is equal to HCF multiply LCM, isn't it? Now what are those two numbers? 28x multiply with 28y should be equal to 812 multiply 28 or 28 multiply 812, isn't it? HCF multiply LCM. Therefore x multiply y should be the product of these two, 28 multiply 812 divided by 28 multiply 28, cancelling this 28 and this 28, and 812 divided by 28, you will get 29. Now since xy is equal to 29, which is a whole number, hence we can say that the two numbers can have HCF and LCM as 28 as and 812 respectively. Clear? Now you just check whether this value of xy is a whole number or not. If it is a whole number, then they can have, those numbers can have HCF and LCM as they given HCF and LCM as per the question. Otherwise, if it is not a whole number, then you can say that no, they cannot have, the two numbers cannot have HCF and LCM as given in the question. Okay, you just have to check this value of xy is a whole number or is a rational number, is a fraction or a whole number. If it's a whole number, then we can say that yes, otherwise the answer will be no. Is clear to you? Now we have come to the end of this part 5. We will discuss the next part in our next class. Okay, bye to all of you.